We've all seen the amazing demos, right? AI that can whip up code, generate incredible art, even hold a pretty convincing conversation. But what happens when that same AI steps out of the lab and into the messy, unpredictable real world? Well, it turns out that final step, that last mile, is by far the hardest part. So let's dive into this huge challenge of making AI something we can actually rely on. It all kind of starts with stories like this. Get this. A few clever people figured out they could manipulate a Chevy dealership's AI chatbot, and they got it to agree to sell them a brand new pickup truck for just a single dollar. Now, that's hilarious for sure, but it's also the perfect snapshot of how easily these complex systems can just completely break in ways nobody saw coming. And that right there brings us to the core idea we're talking about today, the last mile problem. You know, it's one thing to build an impressive AI demo over a weekend. It's an entirely different thing to make that AI so solid, so dependable, that a major company would trust it with their customers or their critical operations. That is a whole different ballgame. So why is this so incredibly hard? In our first section here, we're going to dig into the brittleness of AI and really unpack why the old school ways of testing software are just completely failing us in this new era. For the longest time, the standard way to test software was to use something called a golden data set. Basically, you'd get a bunch of experts to create a fixed list of questions, each with one single correct answer. Then you run your program against it. If it gets the right answers, hey, it passes the test. Simple, clean, done. Well, for generative AI, that whole method just falls apart. First off, a static dataset gives you terrible coverage. It might test a few hundred scenarios, maybe 1,000, but it completely misses the millions of other weird corner cases that real people are going to throw at it. And second, how do you even decide on one correct answer when the AI's response could be creative or subjective or have a lot of nuance? It's basically impossible to score that way. Now, a lot of people think the hard part about AI is that it's non-deterministic. You ask it the same thing twice, you get two slightly different answers. But honestly, that's manageable. The real danger, the thing that keeps engineers up at night, is something called brittleness. This is when a tiny, innocent-looking change in the input causes the AI's output to go completely off the rails. That is exactly what happened with that Chevy bot. Okay, so if the old way of testing is broken, what's the new way? Let's move on and check out the solution. Some folks in the field are calling it AI hazing. It's all about pressure testing these systems to make them stronger and find their breaking points before they get out into the wild. So AI hazing or fuzz testing is all about flipping the script. Instead of just waiting for your users to accidentally break your AI, you build an automated system that relentlessly tries to break it for you. It runs massive scale simulations to actively hunt for those weird corner cases and bugs that you'd otherwise never find. And in theory, the process is a pretty simple loop. Step 1, the system generates a stimulus, some kind of input to poke the AI with. Step 2, a judge looks at the AI's response and gives it a score. And step 3, this is the really clever part, the system uses that score to guide its search, to intelligently figure out what to try next to find a failure. And then it just repeats that loop over and over, getting smarter and smarter each time. Now, that sounds great in theory, but making it actually work is incredibly tough. Two of those steps in particular, judging the response and generating the input, are just huge technical challenges. So let's take a look inside the engine room and see how it's done. And right away, you run into this giant paradox. The easiest way to automate the judging is to use another AI, right? They call it LLM-as-a-judge. But hold on. If the AI you're testing is unreliable, what on earth makes you think the AI that's judging it is any better? How do you quality assure your quality assurance AI? Because the reality is, a standard off-the-shelf AI judge is riddled with flaws. It can hallucinate facts just like any other LLM. Its scoring is totally uncalibrated. Its idea of a 3 out of 5 is completely arbitrary. It even suffers from biases, like scoring an answer differently just depending on whether it's shown first or second. It's just fickle and unreliable. The solution to this is a really fascinating concept called scaling judge time compute. The idea is, instead of having an AI make one quick snap judgment, you invest way more computational power into the judging process itself. You create a much more thoughtful, robust, and reliable evaluation system. And the results from this approach are pretty mind-blowing. Check out this chart. It shows a system called Verdict, which uses a cheaper, smaller model like GPT-4o Mini.
but it's organized in a much smarter way. It makes the model debate itself and verify its own reasoning. The result? It actually achieves higher accuracy at judging than way bigger, more expensive models like GPT-4. We're talking better performance at a fraction of the cost. That's a huge deal.
Okay, so we have a reliable judge. That solves one massive problem. But that's only half the battle. The other giant challenge is finding the right inputs to test with in the first place. I mean, the space of all possible things a person could say in natural language is practically infinite. How do you find those few tiny needles in that cosmic haystack that will actually break your system? You don't do it by just guessing randomly. You treat it like a guided hunt. You frame it as an optimization problem. The goal is very specific. Intelligently search for inputs that will cause the AI to get a really low score from your super smart judge. The system uses these advanced algorithms to methodically zero in on the inputs most likely to cause a total failure. So we've got a smart judge and a guided search. Does this whole AI hazing idea actually deliver in the real world? Let's jump into some real-world results and find out. All right, case study number 1. The biggest bank in Hungary. They built an AI app to help customers figure out loans. The catch? For legal reasons, it absolutely had to follow a strict 18-line code of conduct, no exceptions. By using a hazing platform to basically act like an adversary trying to break the rules, they found a ton of critical vulnerabilities they'd never even thought of. That let them patch the holes and finally deploy the app safely. Now let's look at something even more complex. A Fortune 500 bank wanted to use AI voice agents for debt collection, a super sensitive and highly regulated job. In this case, the hazing system had to test more than just text. It had to test actual audio signals, adding in things like background noise and static on the line to see if the AI could still perform reliably under pressure. And the result of this automated test was just staggering. The bank's own internal team of humans had spent 3 months manually looking for problems. The hazing platform? It found the exact same critical issues in just 5 minutes. 5 minutes. That just shows you the incredible power of this automated adversarial approach. Which really brings us to the main takeaway here. If we want AI to graduate from being a cool demo to being a truly trustworthy part of our world, we can't just cross our fingers and hope for the best. We have to build systems specifically designed to systematically and relentlessly try to break it first. And that leaves all of us with a really important question for the future. As we hand over more and more responsibility to these AI systems, in finance, in healthcare, in our cars, how can we ever be sure that they've been pressure tested enough? How much hazing is enough for us to truly trust them?